So let me read problem number 4 from the Momentum Exam Review. It says 2 spacecraft are about to dock. The first has a mass of 12,000 kilograms and is moving 2 meters per second to the right, while the other is moving to the left at negative 0.97 meters per second. After docking, the spacecraft are moving together with a velocity of negative 0.45 meters per second. What is the mass of the second spacecraft? So you're given 2 spacecraft, and you're given their initial velocities, and together afterwards they're moving to the left still. And so we want to know what is the mass of the spacecraft if all this is true. A couple of ways of doing this one. I like to start off with collision problems, saying the initial momentum equals the final momentum, and then I like to put in the numbers at the end. So I'm going to solve all this, and it's a little algebraically messy. But so this is the initial momentum of my whole system. So what is the initial momentum of my system? Well, both objects are moving. So it's m1 v1 initial plus m2 v2 initial. Okay, and that's going to be equal to the final momentum of the system. And now, here's the thing. I'm going to try to solve for m2. So I'm just going to say this is going to be m1 v final plus m2 v final. They both have the same final velocities. Usually we add the masses together, but we're trying to solve for one of the masses, so it doesn't make any sense to factor it out. Or factor out the final velocity. So we're just going to leave it like this. Now, what I know m1, I know the initial velocities, and I know the final velocity. The only thing I don't know is this guy. And, oh, but look, it's in 2 places. So basically this becomes a big algebra problem to solve for m2. So let's put everything that's got m2 on one side and put everything that doesn't have m2 on it on the other. So I get m1 v1 initial. I'm going to bring that over here, minus m1 v final. And that's going to be equal to m2 v final minus m2 v2 initial. And now I can take this expression and factor out m2. That is what I'm trying to solve. So m2 is equal to v final minus v2 initial. And notice this is just delta v for the second object. Now I just need to divide all of this by this, so I get m2 is equal to m1 v1 initial minus m1 v final. And oh, you know what I can do? Let me just do this, make it look a little bit nicer, save a little bit of writing. Look, I can factor out the m1 v1 initial minus v final, which is really v1 final, and then divide by this right here, v final minus v2 initial. Now I can plug my values in. This isn't too bad. m1 is 12,000 kilograms. V1 initial is 2 meters per second. Minus V final. What is V final? Negative 0.45 meters per second. Divide that by negative 0.45 meters per second minus, and V2 initial, which is negative 0.97. So I have to do all that on a calculator, and let's see what we get. I'm going to start with, well, 12,000. 12,000 times this. Well, 2 minus negative 0.45 is just going to be 2.45, right? So times 2.45. And then I'm going to divide that by negative 0.45. And now minus a negative, I can just go plus 0.97. Oh, and I screwed up. I didn't put a parentheses in here, so let me do that. Parentheses, negative 0.45 plus 0.97, close parentheses, equals. And when you do that, you get 56,538 kilograms. Of course, that's a ridiculous number of significant figures based on what's given. So I'll just say 3 significant figures, 56,500 kilograms. Okay. Now, one of the things you can do, and I almost did it when I was typing it into my calculator here. Let's see if I can turn this so you can see it. Is that I took the answer from multiplying 12,000 times 2.45, and I almost I at first forgot to put that parentheses in there. So when you do that subtraction on the bottom, if you don't do the parentheses, you're going to get the wrong answer. Because in order of operations, what it'll do is it'll divide that answer from the top by negative 0.45, and then it will add 0.97 to it. So, and that might be where some of you got the wrong answer if you did it wrong. But anyway, this all comes from this. One other possible way of approaching this, though, that will get you the same answer, is you can say, hey, the change in momentum of object 1 is equal but opposite to the change in momentum of object 2. This is another way of doing these problems. And if you do this carefully, you'll get the right answer, you get full credit. Well, what is the change in momentum of object 1? It's m1 times delta v for 1, which is v final minus v1 initial, is equal to negative m2 times v final minus v2 initial. And so this is a little bit easier because, look, there's m2 already by itself. So I can solve for it. m2 equals m1 v final minus v1 initial divided by, well, look, negative this. Well, what is negative this? You can just switch the order of these. This becomes negative v final plus v2 initial. So I can put v2 initial minus v final. And I've got the wrong thing. What did I do wrong? What? Oh, I see. They are this. I just switched the order of the other thing. What's different about these two? If I switch the order of this, I'll get that. But if I switch the order of this, I have to switch the order of this to get that, so the signs are the same. I just switched the order of the wrong thing. Take this negative, multiply it on the other side, multiply both sides by -1, then switch the order of this, and then you'll get the same thing. So, I mean, it's another way of solving the problem, and you'll get the same answer. Any questions? Okay. That is all.